Now see this. Here what I am doing is I am trying to find the matrix or the this is the text given to me. Let's say this text or document is given and I want to convert this document into some matrix in order to give it to my machine learning model. So for this I have used some libraries. The first library is NLTK, Natural Language Toolkit. It is having some tools to deal with the data. Then I have a library for regular expression. RE stands for regular expression. Then I have stop words so that I can compare my each word with the library of stop words. If it is available in stop words, then I can remove it. If it is not available, then I can include it in my corpus. Because I have to remove the stop words, I need this particular library. Then I have used a library called Porter Stammer for stemming. This is for stemming. Either I will use stemming or I will use lemmatization. So this is for lemmatization. This WordNet lemmatizer is for lemmatization. So either I will use Porter Stammer or I will use WordNet lemmatizer. What you should do is for each of the project you should try both of them, Porter Stammer and WordNet lemmatizer, and work on it and try to find what is the accuracy using stemming and what is the accuracy using lemmatization so that you can do a comparative study. After importing all the necessary libraries, let's say I have executed this particular thing. Now I have this particular document. I have just simply taken it from the Wikipedia and I have created an object for Porter Stammer. If I am doing stemming, then I will create a object of Porter Stammer. If I am using lemmatization, then I will create the object of WordNet lemmatizer. Then the document, you can see here, the document is having few paragraphs. So this is one paragraph. After this, I have this one paragraph. Then this is another paragraph, 3 paragraphs, and the last one is this 4 paragraphs. There are total 4 paragraphs in my document. But I am not interested in paragraphs. I am interested in sentences. You have also seen while doing bag of words or TF-IDF, I have sentence 1, sentence 2, sentence 3, and then in every sentence I have gone into single word. So I am not interested in paragraphs. So what I need to do is I need to convert this paragraph into sentences. For that I have NLTK, Natural Language Toolkit .sentence. I have Natural Language Toolkit sentence tokenize. That is sent_tokenize. It particularly find the full stop. For example, this. It starts from the last full stop till the next full stop and consider it as a one sentence. And it create a list of sentences. So now if you if you try to run this and see, there is sentence. This is one sentence. Then here we have another sentence, then we have another sentence. So it is converting the whole paragraph or whole document into list of sentences. I have also created one more variable, corpus, because sentences or paragraph is the variable which is having uncluttered data. It is having cluttered data, having lot of special symbols, numbers, and having stop words and everything. I will create a new variable corpus in which I will include the only clean data. So right now it is empty, but after doing the cleaning, I will add the data into my corpus. After this, I have run a loop, and see this loop is very important. See, for the length of sentences, this sentences is a list. I have run it for number of sentences times. So if there are 100 sentences, the loop will run from 0 to 99 100 times. So I have run a loop for I in range length of sentences. For each sentences I, what it will do is regular expression dot substitute If it is not A to Z, means if it is not English characters, replace it with space. If it is not English character, replace it with space. So if it is P, okay. If it is O, okay. If it is P, okay. But then when it will come to 20, so 2 is not English character, it will be replaced with space. 0 is not English character, it will be replaced with space. Similarly, it will take the whole sentence I and keep only English characters and replace everything else. If it is any special symbol, then also it is not English character, it will replaced by space. After this, I don't want to have capital letters, because if it is having T capital for testing, and in my particular document testing is also coming with small starting with small t. For our machine, capital T testing or small t testing will be treated as different. I want it as one single word, so I have converted my whole paragraph or my whole document into lowercase letters, so that it does not happen. Now my sentence is there. This review is having a sentence having English characters in small letters. It is not having any special symbol. It is not having any number or any fancy characters. I want to have each word splitted now. Why? Because I will take one word at a time and search my stop words and see whether it is a stop word or not. If it is a stop word, I will ignore it because I don't want to include it into my corpus. But if it is a non-stop word, then I will take it and do stemming or lemmatization. So I have taken this sentence and splitted it. Splitted actually take place using space. And now this review is a list of words. Now see this particular line is doing two tasks. One, it is ignoring the stop words, and if it is not a stop word, then doing stemming. See how. Read from here first. For word in review. This review is a list of words. For word in review, that is from the list of words that is review, take one at a time, and if it is not in stopwords.words English library, if it is not in this stopwords library, do ps.stem. This ps is the same object which I have created the above, this particular Porter stemmer object ps. Now I am doing stemming for that word if it is not in my stopwords dictionary. If it is there, then we are not doing it, so it will not be added in review. So this particular review will have only those words which are not in stop words, and stemming is already done. After this, I have joined each and every word with space so that my sentence can be built again, because ultimately I need sentences. So after doing all the cleaning part, stemming part, removal of stop words, I have taken the main words into account and joined back in with space and appended it to my corpus, appended it to back to corpus, which was empty earlier. For each sentence I, for sentence 0, then sentence 1, then sentence 2, it will work. For all these tasks will be done for each sentence. Now if you run this and see the corpus, you can see now we have much cleaner data. This is my data and it is much cleaner. I don't have unnecessary numbers, I don't have unnecessary special symbols, and here the stemming is also done. See here few words, let's see few words. So this is contagious or this is identified. In the original data we have contagious, identified, breathing difficulties, these are the words. But after cleaning, what happen is contagious become contagi, identified become identify, breathing becomes breathe, difficulties become difficulty. So there are lot of words which are already converted into their stem. Also there are many words which are into their original, like we have result, we have year, or we have month, we have COVID, they are in original form. And now this data will be given to our bag of words model, and then we can see how to convert this into matrix of zeros or ones. In bag of words we have zeros and ones, we don't have point values, decimal values. So there is a library in sklearn, count vectorizer. This count vectorizer is used for bag of words and binary bag of words actually. So we have created an object for count vectorizer here. Again, while using any particular library, you need to make the object of it. Just like stemming, we have created an object for count vectorizer here. So count vectorizer is object is CV. So we have run cv.fit_transform. Fit transform is a function which is available in count vectorizer library and which will convert my this whole sentences or whole document into series of matrix or in a series of zeros and ones. So I have given the corpus and converted it to 2 array. So now if you see this X, if I run this and see X, so you can see this is the data which we got lastly. This particular fit transform is taking each word and then finding in sentence 1, sentence 2, sentence 3, if it is available, writing 0 and 1, if it is not available, writing 0. So here you can see 1 is available here. So lot of zeros are there because I have 5, let's say 5 words in a sentence, and I have total number of words are, let's say 1000. So 5 times 1 will come out of 1000 times. In 995 cases it will be 0. So it will have lot of zeros and very less ones. And this is the purpose of bag of words. We have finally converted our data into matrix.